So hello students, welcome to your own YouTube channel. So hope you all are okay, well and fine. So this question has been asked in ESE 2002 examination. Just read the question statement. A 6-pole 3-phase alternator running at 1000 rpm supplies to an 8-pole 3-phase induction motor, right, which has a rotor current of frequency 2 Hz. Then find the operating speed of the motor. You understand the question, right? So an alternator is supplying to an 8-pole 3-phase induction motor which has rotor current of frequency 2 Hz. Now he is asking you the operating speed of this induction motor, right? So operating speed of the induction motor. So out of these 4 options A, B, C, D, only one option is correct, and you have to choose that correct option after solving this question. So operating speed of the induction motor is given by NR, right? It's a rotor speed of 3-phase induction motor. Motor speed NR is given by NR is given by NS, right? NS into 1 minus slip S, right? NS is the synchronous speed, right? At the synchronous speed, your stator magnetic field is rotating in air gap, right? S is the operating slip of the induction motor. Now the slip of induction motor, it is given by S is equal to rotor frequency, let me call this F2, divided by applied frequencies to stator, that is F1, right? So these two formulas belong to induction motor, right? So now just analyze in this question, the supply frequency is not given to you, right? So until and unless supply frequency is not given to you, you cannot calculate the operating slip of the induction motor, is it not? Because operating slip is rotor frequency by applied stator frequency, right? So applied frequency to the stator is not given to you, that is F1. F1 is not given to you, right? So if F1 is not given, you cannot calculate slip S, right, of induction motor, right? If you are not able to find out slip S, then how you will find out the rotor speed of induction motor NR? You cannot find out, right? So first of all, your effort should be to calculate this supply frequency to induction motor F1, right? Is it not? So to calculate the supply frequency, he has given you this data of alternator, right? Which data? That alternator is of 6-pole alternator, right? And operating speed of alternator is 1000 rpm. So with these two data, you can calculate the supply frequency to induction motor F1. How to calculate? See here. So I am going to use the basic relation. F1 is equal to PNS by 120, right? Remember, this NS is the synchronous speed of alternator, right? It is not equal to synchronous speed of this induction motor. Let me differentiate it. Okay, let me differentiate it by, let me call it by NS1, right? NS1 is the synchronous speed of alternator, right? So at this synchronous speed, which is equal to 1000 rpm, NS1 is a synchronous speed of alternator, right? Alternator is synchronous generator, you know, right? Alternator is basically synchronous generator. So its synchronous speed NS1 is given to you 1000 rpm, right? And number of poles on the alternator are 6. So F is equal to Pn by 120. So with this data, you can calculate the supply frequency to induction motor, because this alternator is supplying to induction motor, right? So frequency data of 3-phase induction motor, supply frequency data of 3-phase induction motor is calculated by this data of synchronous speed of alternator and number of poles of the alternator, right? So pole on alternator are 6, right? It is given 6. Synchronous speed of alternator is 1000, right? And divide by 120. So this comes out to be equal to how much? 50 Hertz, right? 50 Hertz. So now this 50 hertz is that frequency at which your induction motor, three-phase induction motor is operating, right? At which this is the supply frequency of three-phase induction motor. Which frequency? This 50 hertz frequency, right? So at this 50 hertz frequency, your three-phase induction motor is supplied, right? So this data was important because you want to calculate the induction motor speed, NR, and for this NR speed you first calculate the slip, and slip will only be calculated by the knowledge of this supply frequency of this induction motor, right? Supply frequency to induction motor now you have calculated, it is equal to 50 hertz, right? F2 you know already, F2 is rotor frequency, it is given in the question, it is 2 hertz, see here, 2 hertz, it is given to you, right? So this data is given to you, and 8 pole are on induction motor, right? So now you can calculate rotor, you can calculate the slip, you can calculate the slip of induction motor. Rotor frequency is F2, F2 is equal to 2 hertz, it is given in the question, and divide by F1, it is 50 hertz, right? So this is equal to how much? 0.04, 0.04, this is slip, right? This is the operating slip of the induction motor, right? Right? So this is one of the important data for calculation of your rotor speed of induction motor, right? Now use this relation, NR is equal to NS 1 minus S. How this relation comes, I have already explained this in my induction motor video, just watch that video on my YouTube channel, right? So now you calculate this speed, motor speed nothing but the rotor of three-phase induction motor speed, right? So NR, it is equal to, now you can easily calculate. So NR is that speed, induction motor speed, right? So R stands for the rotor, right? So induction motor speed NR is equal to NS. NS again you know 120 F by P, from the same basic relation you can calculate. So 120 F, now supply frequency, induction motor is F1, supply frequency to induction motor is now F1, so write F1 here, 120 F1 by number of poles on the induction motor, right? Okay, so now NS, this bracket indicate NS, synchronous speed to induction motor, right? At this speed your stator magnetic field of induction motor rotates in air gap, right, between stator and rotor. So NS is this 120 F1 by P, F1 is supply frequency to induction motor equal to 50 hertz, just now you have calculated. T is the poles of induction motor which is equal to 8, right, given in the question. 1 minus S, so 1 minus S is slip of induction motor, operating slip of induction motor, right? So 120 into F, F1 is just now you have calculated 50, divided by poles of the induction motor is 8, given in the question. 1 minus 0.04, it is 0.96, right? 0.96, right? So you calculate, when you calculate this, you will get how much? You will get this 120 into 50 by 8, this is 750 into 0.96. So 750 into 0.96, it is equal to now 720 RPM, right? So this is the operating speed of induction motor. At this speed your induction motor will operate. So now you understand the approach of this question, right? So the clue was to first calculate this supply frequency to this induction motor, because until unless you know the supply frequency you cannot calculate the slip of induction motor, and if you cannot calculate the slip of this induction motor, then if you cannot calculate the slip, then you cannot calculate the rotor speed. So for calculation of rotor speed of induction motor, first of all you should know the slip, and for knowing the slip, first of all you should know the supply frequency to this induction motor, that is F1, right? F1 is a stator frequency, applied frequency to the stator. You should know it first, right, to calculate the slip. And how to know this applied frequency to the stator on induction motor? So this can be known, this can be calculated, this F1 can be calculated by this data of alternator, by the synchronous speed of the alternator, that is 1000 rpm, and this number of poles on the alternator, that is 6. So these two data are basically given to calculate the supply frequency to this induction motor, because your alternator is supplying your induction motor, right? So 720 is the operating speed you have calculated now. So which option is correct? 720? Option C is correct, right? Option C is correct. So option C, Calcutta, option C is correct, right? 720 rpm, right? So this is the correct option. So with this speed, 720 rpm, with this speed your induction motor is operating, right, for this given data. So you understand the approach, right? So thank you very much. So for all such kind of question, you can visit to this YouTube channel. If you like, you can subscribe the channel. Thanks for watching. Thank you very much. Keep on practicing. Thank you very much. Thanks for watching.